Hello everyone, my name is Fahad and I've been working for GE for over 5 years now. I'm part of the Substation Automation Systems Validation team. I've worked on various SAS products like, for example, D400, D20MX, D25, and today I'm going to be giving you guys a demo on how to configure a D400 and a UR over PRP. D400 is a smart substation gateway. It can be used for monitoring and diagnostic purposes, also for fault recording, and Parallel Redundancy Protocol, which is PRP. PRP is commonly used nowadays because of its seamless communication. It runs over two networks, network 1 and network 2, and if there's any drop in communication in network 1, then still there won't be any halt in communication because it receives information or communication packets over the two networks at the same time simultaneously. So let's get started. In order to configure PRP on the D400, we have to connect a serial port to the maintenance port of the D400. So any null modem cable can be connected. So I have the null modem cable connected to the D400, and I'll open up a terminal window so that I can configure PRP on it. So any terminal program, like the most commonly used terminal program is term. So I'll just open that up. For my system, it's COM port 4. Select OK. Baud rate is default baud rate is 19200 on the D400. So I'll select OK. Hit enter, and this is now I can configure D400 via the maintenance port. Okay, so for the PRP test, we'll have a UR which will be acting as a server, and the D400 which will act as the client. So first I'll configure the UR and set up IC61850 server on it, and then we'll configure the D400 once the UR configuration is complete. So this is the UR setup software. Once any setup software that supports PRP can be used, the device is already connected, so we just need to discover it. So quick connect, Ethernet connect. It's an Ethernet interface. Give the IP credentials and connect. If the IP is properly connected on the network, then in a Vista, the setup software should be able to detect it right away, like it's been detected successfully. The device is added here. You can see. For our test purpose, we'll use version SAN.1, but any version which is SAN.1 or higher can be used because any of those would support PRP functionality. So settings, product setup, communication, network. On the UR, ports 2 and 3, they support PRP connection. PRP is already configured on ports 2 and port 3 with the appropriate IP address, and this IP address would be used on the D400 to make the client and server connection, which I'll demonstrate later on. IC61850, since it's a server, so server configuration, the key parameters to note are the IED name and the server scanning. Server scanning should be enabled, and the IED name, which is shown here, should match up to what we configure in the D400 later on. So this is pretty much on the UR side. If the UR supports, since we're trying to keep a very basic PRP we're trying to establish a very basic PRP connection. If the UR supports digital inputs, digital outputs, accumulators, analog outputs, analog inputs, then all of them can be mapped on the D400. But since we're trying to only establish a basic PRP communication for our test, we'll only configure a digital input point and run the PRP test just to ensure that it's working properly, and anyone who wants to set it up can do it without any problem. So this is all from the UR side, and now we'll configure the D400. We'll be configuring PRP on the D400 right now, and I'll show you how it's done if you have a D400 unit, all we need is release 5.1 with service pack 1. Once that's there, open up the terminal window, log in with the credentials, and then start configuring PRP. Please note, as I mentioned, release 5.1, which is shown as 510, build 40 with service pack 1. That's the one you need in order to use in order to configure PRP. So we type D400 CFG, go into the utility menu, configure the network interface, go to Parallel Redundancy Protocol, which is number 3, enable Parallel Redundancy Protocol 1. LAN ID, we can just select the default value, which is 7 at the moment. It should be fine. Live check, set the default value. Since we want to do it on both LAN A and LAN B, that's why we'll have to do it on both net 1 and net 2. Please keep in mind that D400 uses a daughter card which goes on top of the main CPU. In order to use network 2 on the D400, we must have the daughter card in place. Otherwise, we would only be able to use network 1 and not both networks, network 1 and network 2. But for PRP, we need both networks, network 1 and network 2. So let's configure network 1 first. Share network and non-PRP traffic, no. We only want PRP traffic and no interference, so no here. Well, network for network B is net 2, so 1. This is for the second network, LAN B. Yes. PRP will remove net 1 interface, that's fine. Continue. You want to take backup on net 1. If you already have a configuration on net 1, then it's recommended to take a backup on network 1 before we configure the PRP. But since for my test I currently don't have a configuration network 1, that's why I'm going to say no backup required. You sure you want to remove configuration net 1? Yes. Please press any key to continue. So now same thing for network 2. Since I don't have configuration on network 2, that's why there is no backup needed. I can safely remove it from my D400 in order to configure PRP. Yes. No backup needed. Yes. Net 1 and net 2 communications have been successfully removed. Now we can configure the PRP setup. Configure PRP interface, number 1. This is the Parallel Redundancy Protocol menu. From here we configure PRP interface. Static IP, we have to give the IP where the D400 client would be communicating to the slave devices. So let's give it an IP where the PRP connection would take place, 192.168.168.23, as I previously mentioned the diagram too. Give it a valid subnet mask. Yes. And right now, since we're not running redundancy, so that's why only the maintenance IP is good enough. But if you're running PRP and redundancy at the same time, then it's good to have the maintenance IP, which can be used for PRP, and the redundancy IP, which can be used for the redundancy test. And both of them will be isolated so that there is no conflict, which makes it even more reliable and easy to use. Now PRP is configured. In order for the settings to take effect, we'll have to do a reboot. So let's just do a reboot and start configuring PRP. Now all we did was we configured an IP for the PRP test. Once the device comes up, we'll use the D400 setup software as config and map the IC61850 files from the server to the client. The device is the D400 device is back online after reboot. So in order to see if the PRP settings are active or not, type in the credentials and then type the command if config. This will show you whether PRP is set. Okay, bond 0 is a representation that PRP is currently running. So IP settings have taken effect, and now we can start configuring the IC61850 connection from the setup software, which is called sgconfig. So let's just minimize this and open sgconfig. This is how sgconfig looks like once you open it up from your programs. And now we need to create a new project for the D400. Let's give it a name of D400 PRP. Select OK. And let's drag a D400 device from local repository, D400, and device name would be since we're configuring it over IC61850, let's give it IC61850. IP address would be we can give the IP of the PRP which we just configured a few minutes ago. And now once I do a read firmware, it should automatically detect the firmware that's already installed on the compact flashes that are installed inside the D400. So we log in with the HMI credentials, which are supervisor is the username, password is super, SUPER 123 $, all small letters. And now when we try to log in, it should detect the firmware that's running on the compact flash cards. D400 uses 2 compact flash cards, primary and secondary. For our test, we are using 1 gigabit primary and 1 gigabit secondary. So we can specify the size of the compact flash cards here. And since the appropriate firmware and service pack 1 has been detected, so we can just the settings on this tab is complete. Now we move on to licensing. In D400 you need a license to run IC61850. We already have the license file installed, but in sgconfig, since we're trying to configure the IC61850 loader, so we have to check this in order to use that particular feature. Otherwise we won't be able to get into the IC61850 loader in sgconfig. So this is done. Please note that you see a red dot here. This red dot means that we recently made some changes to the configuration, and once all the settings are in place, the configuration is complete, then in the end we'll generate the configuration so that the red dot is not there anymore. And however, if some error messages are generated, then this red dot would appear again. It's an indication saying that the configuration is not properly configured. So once that's done, then it should be eliminated. So right now, since the device was properly configured, once sgconfig was verifying whether the appropriate firmware and service pack is installed, and we selected the correct compact flash size, that's why now the red dot is not there anymore. Now the next step is to configure IC61850. So right click on the device, go on IC61850 and select loader. What this would do is this will open up a new interface, and in here we will configure the client and server connection. This pop-up will be generated once we're trying to configure the D400 from sgconfig for the very first time. We don't necessarily have to sync from the device, so I'll just do not show this message for this device again and click no. Okay, this is a D400 which we just configured. Now we have to add the server config. In order to add the server configuration, we have to create a voltage area. Let's give it any name, like for example, let's say test Voltage area is there. Now we have to do a bay area. Give it any name, let's say bay 1. Drag it inside the voltage area. And now this is the server configuration. Server configuration in our case is a UR, so we'll drag this inside the voltage area. And now once the device has been dragged, it will show you two options. Either you can retrieve the ICD file from the UR, which is option 1, but in my case I will do invoke IC60850. Both of them are very straightforward, very easy, since the configuration hasn't been saved yet. So for now, let's just select yes. This is the information for the UR. Version 7.1 and IP address of the UR is 192.168.168.33. Select OK. For this, this pop-up is generated if you're configuring the device for the very first time. Just select yes. Please note, as I mentioned previously, the physical device name that is shown up here should match up to the physical device name that was presented in the UR. In the UR, the device name is shown as IAD name, and that's the one we are going to configure in the D400 so that there is no conflict and everything happens smoothly, like there is no problem in configuring the points. So UR server has been added. Now we need to configure the IC60850 points. Right click on the server device, edit configuration. Go to assign dataset retrieval mode. These are the number of data sets that are currently available in my UR, the UR that I have, which is acting as a server. Let's just pick one of the data sets since we're trying to establish a basic PRP connection. However, what you can do is, if your UR or any other slave device, any other server device supports the data set that has digital outputs, digital inputs, analog outputs, analog inputs, or accumulators, you can select any one of them or all of them. They should be fine, but for my test, we're going to select GGI01, which has status points only. So report this. UR has IC60850 addition 2. Addition 2 dataset is indexed. So once the dataset has been added to this table, you have to select an RCB reference. Let's select an RCB reference which is a buffered report and has a valid index. Like this is a buffered report, BR is for buffered report, and it has a valid index. So we'll just select this one. You can also specify the polling interval. For my test, we'll just leave the default values as they are. And now go to the map points, which is the second tab. In the second tab, these are the logical nodes for the UR. All of these logical nodes are currently present and running in the UR, but I will only select the one that I mapped in the dataset retrieval mode, which was GGI01. So let's just select GGI01 here. Yes, all of the points which are in GGI01 will be selected. It has 3 analog input points and 8 digital input points. So it also supports analog inputs, whereas I thought it only supports digital inputs, which is good. So we have 3 analog inputs and 8 digital inputs. We select apply. If there is no mismatch, then applying this would work, otherwise an error message will be popped up. Now select OK. IC60850 point mapping has been done. Points are properly configured. And now what we can do is exit and save changes. Since we made some changes, that's why the red dot is shown up again. So now what we need to do is generate the device. Right click on the device, go into IC60850 and generate. If there are no error messages in the configuration, then the device generate would be okay, and the red dot should disappear. IC60850 point mapping is complete. Now we The next step is to make the physical connection and then we can see whether the D400 and the UR are properly communicating or not. The last step is sync to device, which the configuration will be sent to the device, but I will do that once I verify that the physical connection is in place. The list of equipment that we need for the PRP test are shown in this diagram. There is a D400 with the latest release 5.1 plus service pack 1, and then you have the UR with release 7.1 or higher. Any release that supports PRP can be used. On the D400, LAN A, which is Ethernet card 1, would be connected to switch 1, and LAN B of the D400 would be connected to switch 2. D400 uses Ethernet card 1 and Ethernet card 2 for LAN A and LAN A and LAN B connections, whereas the UR uses ports 2 and 3 for PRP connection. What that means is LAN A of D400 connected to switch 1, port 2 of the UR connected to switch 1, LAN B of D400 connected to switch 2, and port 3 of the UR connected to switch 2. All of these devices, the D400, UR, switch 1, switch 2, would be connected to the PC. PC would be used to configure the setup software for D400 and UR. The setup software for D400 is sgconfig, and the setup software for UR is under Vista. It's only a diagram. It shows how the connection would be, but now I'm going to move on and show you the physical connection, how to connect the two LANs, network 1 and network 2, and how to make the server and client PRP connection over IEC60850. Please note that for our test, UR is the server, D400 is the client, and communication protocol is IEC60850. Okay, now I'll show you the physical connection, how the D400 and the UR are connected together. On the D400 you have two Ethernet cards. This is Ethernet card 1 and this is Ethernet card 2. Ethernet card 1 would be connected to switch 1, and Ethernet card 2, which is LAN B of D400, is connected to switch 2. So switch 1 is LAN A, switch 2 is LAN B. Same logic applies to the UR connection. Ports 2 and port 3 is the PRP port on the UR. Port 2 would be connected to switch 1. Port 3 would be connected to switch 2. This is a physical connection, and we also have a connection from switch 1 to the PC so that we can monitor all the flow of traffic from the setup software on the PC. So this is pretty much the physical connection, and the rest of the demonstration will be done on the PC or the setup software. Physical connection is done. IEC60850 point mapping is complete. Now the next step is to sync the configuration to the D400. So right click on the device, go to communication, sync to device. We can select no, because we don't necessarily have to sync from the device because we're trying to sync to the device. So no. And now we have to give in the HMI credentials, which are supervisor, username, and password SUPER123$. Once the configuration is synced to the device, then we can start using the HMI. And the HMI should show, if the configuration is properly done, then the HMI should show that the point mapping is valid. All the status points and the analog input points are reported as online to the D400. So we'll just wait for the configuration to be synced to the device. Okay. Synchronization was successful. Now we have to wait for a minute before we can log into the HMI. So I'm just going to hit OK, and then wait for close to a minute before I log in to the HMI screen. Physical connection was good. and no error messages were reported while we were trying to configure PRP in D400 utility menu, and even IC650 point mapping was reasonable, so everything should work out fine. Now we go into the HMI, right click on the device communication, connect. This is the HMI of the D400. You need to have the latest Java version installed in order to use the HMI. Here you can see that the Java version is loading up in the background. So once the HMI comes up, then we have to log in again with the credentials, which I have repeated many times: supervisor username and password super $123. This is how the D400 HMI looks like. And first what we're going to do is verify whether the connection has been successfully established. That can be done by going into the configuration page. In configuration, you will see all the connections that are currently present in the D400. Here you can see that the UR IC650 connection is created, and now to see whether the D400 is communicating to the UR or not, we go into the communication summary page. The efficiency is close to 100, which is good, and it means that it's communicating to the UR device. Now to see whether the points are also being reported from the server to the client, you go into the point summary page and select details. Analog input points are online, and this is a correct value that is reported to the client, because using any like if the IC650 connection is valid, then health, BEH, and MOD, the point value for these parameters would be shown as 1, so it is properly reported in the D400. Now the digital input points, they're also shown up as online, which is an indication that the point mapping was properly done, and the server is also correctly reporting the appropriate points to the D400 client. Accumulator is where you see that the message sent and message received are incrementing. It's another indication of a successful communication. And now the final verification that we need to do whether PRP is active or not is to check the system status manager, which would be in point summary. Click on point summary, applications, and then system status manager, which is SSM details. Here we see that PRP is running fine. Packets received, total packets received on A, and total duplicate packets received on A. You see both of these incrementing. And LAN B, total packets received this, total duplicate packets received is this. The reason why you're seeing more packets on LAN A is because, as I mentioned while I was making the physical connection, while I was demonstrating the physical connection, LAN A is connected to switch 1. Switch 1 is 100 megs per second and is receiving packets faster than switch 2. So the packets are coming in faster on LAN A, and since it's receiving 2 packets, only the LAN which receives packets first, it would increment it, and the second packet would be disregarded, and that's why you see total duplicate packets received on LAN A is a higher number. So, and message sent, message received on the IED is also incrementing. It's an indication that PRP test was properly done. So now what I'm gonna do is I'm gonna disconnect LAN A, and then you'll still see that the flow of communication is good. There is no halt. Once that's done, then I will reconnect LAN A and disconnect LAN B. You'll still see that communication is seamless and no problem has been reported. So now, in order to verify whether the PRP test is running successfully, I will disconnect LAN A and the communications would still be okay, because since packets are getting received on LAN A and LAN B simultaneously. So now I will disconnect LAN A. Okay, LAN A is disconnected, and now you should see that LAN B is incrementing. This is LAN B, and message sent, message received should also increase, should also increment. So let's just give it a couple of seconds before we see that it's working properly or not. See, now it's only receiving on LAN B. This is incrementing, this is not incrementing because LAN A is disconnected, and we did not see any more error messages. The reason why you see one message error on startup, this is only on startup, because whenever you have a buffered report, it will, during initialization, it will send one error message, but it doesn't create any confusion. So we can just ignore it, because it doesn't have much of an impact on how the PRP communication is running. But this will only be on initialization. If you're getting it regularly, it means that there's something wrong with the communication. Packets are received on LAN B, and the reason why it's not incrementing rapidly is because it's a 10 meg switch, and the flow of information on the 10 meg switches would be a little bit slower than on the 100 meg. Like this was incrementing really rapidly because it was a 100 meg switch, but now this has stopped and LAN B is incrementing, which means that there was no drop in communication. Now what I'm going to do is I'm going to reconnect LAN A and disconnect LAN B. So you will see that LAN A would start to increment again and LAN B will stop. Okay. Now LAN A is connected and LAN B is disconnected. This should increment, this should start increment, and this should just pause because LAN B is disconnected. So let's see, it should start incrementing in a few seconds. As long as there is no error message or no timeout, it means that it was a seamless communication and no drop of network packets has been reported. Now you can see that LAN A is picking up, as in it's communicating over LAN A. LAN B has stopped because the connection is disconnected, and you see that the message and message received is also incrementing. We'll just see a couple of increments before we reconnect LAN B again, and this basically demonstrates that the PRP test is running well and there is no drop in communication. If you have a system where polling is happening regularly, like every second or after every few seconds, then the increment on the packet received on LAN A and the message sent, message received on the IED would be very fast. But for now, since our polling interval is not very fast, that's why the information is coming in after every few seconds. So LAN A is working well, and this basically concludes our PRP test. Now I will reconnect LAN B again. LAN B is reconnected. Now we should be able to see that PRP on LAN A, packets received on LAN A and also on LAN B are incrementing. And the good thing is we did not see any more error messages or message timeouts, which is an indication that the PRP test was a pass. This concludes our PRP demonstration on D400 and UR. Hopefully it was beneficial. If you have any questions, then contact training.multilin.com, and hopefully you enjoyed the training.